So section 1010 is about estimating one of these series. We talk about how we know whether they converge or not, but we haven't talked about how do we know what they converge to. And so that's what this section is about. So your new objective is I can approximate the sum of a series. So the first thing is we are going to estimate this sum and just see how good of an estimate we're making. So first of all, I always recommend write out a couple of terms so you know what this is. So if I plug in n equals 1, I would get a positive 1 over 1. If I plug in n equals 2, I'm going to get a negative 1 over 4. And so on, right? So if I plug in n equals 3, I'm at positive 1/9, and n equals 4 would be negative 1/16, etc., right? So I don't want to add up infinitely many terms because that would be painful. So I'm not going to. Also, it's not possible. I'm just going to stop and estimate the sum by adding up the first 4. That's an estimate. It's not going to be perfect, but it's an estimate. And I can even do it by hand or maybe with a simple calculator. So I could say, all right, I'm going to find a common denominator. And when I find that common denominator, it's going to be so when I find a common denominator, it's going to be 16 times 9 because 4 goes into 16, and 16 times 9 is 144. So I'd have 144 as a denominator. And so then I'd have 36 144s plus 16 144s minus 9 over, 9 over 144. And when I add all that up, I get 115 over 144. So this is an estimate of the sum of this infinite series. It's not perfect. It's just an estimate. And it's an estimate only using 4 terms because I didn't want to include that 25 because that would make my common denominator just terrible, and I don't want to get into that. So I'm going to say, well, it's approximately equal to 115 over 144. And now I want to know, well, how good of an estimate is that? Like, okay, so it's 115 over 144. I only used 4 terms. They're infinitely many. How bad was it? And so what we're going to do, I'm going to look at that series again. First of all, is our estimate too big or too small? Is there any way we could know whether it's too big or too small? And I'd recommend that you think about that a little bit. So we said we're just going to use these 4 terms, and we estimated that we had a value of 115 over 144. These are the terms we didn't use. So here's one way of thinking about whether our estimate was too big or too small. If we group our terms in groups of 2, because a 25th is bigger than a 36th, this value would be positive, and same with this value, and actually infinitely on forever, those values would all be positive. So what we know is that we would be adding a bunch of positive values if we had included all of the terms. So our estimate is too low. It's an underestimate. It's an underestimate because if we add the rest of the terms, we would get a slightly larger number. And now I want to look at, okay, so it's an underestimate, but how bad is it? And to do that, I'm going to group things a little bit differently. So I'm going to look at the error here, and I'm going to say, well, that's plus 125th minus 136th minus 149th. Because if this is going to be positive, if I distribute, I would get a positive. Minus 164th minus the next term, which would be 1/81st. So this value would be positive because 1/36 is bigger than 1/49. This value would be positive because 1/64 is bigger than 1/81st. So our estimate, 1/25th minus a whole bunch of positive values. So the next term is the upper limit of how, and it's actually definitely going to be a smaller, it's going to be a bigger error than what the actual error is. If we say, well, I don't know exactly how good our estimate is, but I know that it's within 1/25th of the actual value. In fact, because I know that the actual sum is slightly bigger than this, I know that the actual sum is going to be between 115 over 144 and whatever 115 over 144 plus 1/25th is. So we have just figured out a really good estimate of what the value of the sum is, and we also know how good it is. If we need this to be more accurate, we would take more terms. Also, the same grouping applies. If we had used one more term, then our estimate would be too high, and it would be within 1/36th of the actual value. You can play with grouping in order to see that that's true. But if we include one more term, it'd be too high. If we include then one more term, it'd be too low again. Remember, the alternating series kind of bounce back and forth, getting closer and closer to that sum. So here is how the alternating series error bound works. If you have a converging alternating series, the nth partial sum is off from the actual sum of the series by no more than the next term. I put absolute value signs around it because that tells you the size of your error, but you can also look at the sign of it to know whether you are an overestimate or an underestimate of the value. We're going to do one more example together, and in this example we are looking at using just two terms to estimate the sum of this series. So that's how we're going to start. So the first term, if I use n equals 0, would be positive. Oops. So positive 1/2 times 3 plus negative 1/2 to the third times 5. So if we add those together, we're going to use a common denominator of 120. So we'd have 20. Well, this would be 1/60th, so we'd have 20 over 120. That would be 1/6, not 1/60th. And this would be 1/40th, so we multiply by 3 and we have 3 over 120. And so our estimate is that it is 17 over 120. Okay? So this is our estimate, and now we want to show that that is no worse than 1/200th of the actual value. So the way we do that is the next term would be, oops, there we go again. If I use n equals 2, I get 1/2 to the 5th times 7, or 1/32 times 7, or 1/224. So I know that my error bound, the largest that the error could be, is 1/224. So I know that 1/224 is less than 1/200. So I have just shown using alternating series error bound. I'm not going to make a video of the next problem, but I recommend that you try the next problem, and I'll post an image of my solution to the next problem. So this is the next one to try. All right, good luck, have fun.